Hey guys, my name is That Quiet Kid, and today we are going to do a room called Deja Vu on Tryhackme. And this in this room we will exploit a recent code injection vulnerability to take over a website full of cute dog pictures. So let's start this machine and download our VPN file to connect to Tryhackme. You can download it by going to your profile and clicking on Access, and from here you can download your configuration file. I have already downloaded it, so let's connect to Tryhackme. The command is open VPN and your configuration file. Mine is mrrobot_tryhackme.ovpn. And when you see initialization sequence completed, which means you have connected to Tryhackme VPN, I can confirm this by typing ifconfig, and you will see a interface by the name turn0, and here's my IP. Let me show you. Now I have disconnected to Tryhackme, and if I run ifconfig, I'm seeing just two interfaces. One is Ethernet 0 because I'm using NAT network, and one is my local network. And now I have connected to the Tryhackme VPN. Let me run ifconfig now, and you can see that this is my IP. So let's start this room. Okay, this is the IP. Let's run nmap scan, but I have already ran it. So let me show you the nmap result. Its two ports are open, SSH and HTTP, which is in Golang. So let's go to port 80. Okay, while this machine is booting up, so let's read. This room aims to teach exploring a web app to discover potential vulnerabilities and exploiting a discovered vulnerability with Metasploit privilege escalation by path exploitation. So this is actually a walkthrough room, and some elements will rely on individual research and troubleshooting. So let's answer this and move forward to task 2. I think for web enumeration we will use burp suite. So let's start our burp suite. I am connected to the VPN. You can run nmap by specifying nmap-a, which is aggressive scan, which does the basic scripts and TCP ports and OS version detection, and specifying the speed T4 and okay, and specifying T4, which is the speed. It is from T1 to T5. I'm using T4 and pasting the IP, and it will run. Okay, the machine is taking a bit long. Let's see, has it booted up yet or not? Okay, burp suite has started. Just let me. Oh, the host is down. Okay, I think I'm connected to the VPN. Okay, there is some error. My VPN, I guess. Yes, now the VPN has connected, and I think I should be connected to that machine now. Let me run it again. I think now it works. So the machine has successfully booted up. Our VPN error, I don't know why I was having that error, but now it's working. So let's move on forward. From nweb service version detection, we know that the backend is built in Golang. You can see from here. Let me show you the nmap scan. It's Golang net/http server, and this hopefully means dynamic content that can be that we can explore. So I guess we open a burp suite with your browser of choice, and we can start exploring the site. Click around the website. Can you find any developer comments? So let's see page source. Yes, we can see what should happen when we click on a picture of dog. How do we style it to make it sure that it's clickable? Okay, it is. Hmm. It shows id parameter equals to 0. Let's see. Okay, so we can access it from here. We can access all the photos from changing the id parameters from the url itself. Okay, okay, let's see. Okay, I guess 7 is the total number of photographs on this website. So okay, can you find the page that gives more details about a dog photo? Yes, we can by just clicking on the dog photograph picture. Perform an nmap scan on perform an nmap scan of the target. What version of ssh is in use? It's actually open ssh 8.0 protocol. This 2.0. Let's paste it and move forward to task 3, which is the vulnerability discovery. So diving deeper. Okay, it is saying us to run GoBuster. Let's copy it from here. Go into our Kali machine and let's run GoBuster from here. GoBuster -, suid, which means directory dash u is for specifying the URL. Dash v is for using the word list, which I am using medium.txt. However, it says to use big.txt, but I think this also works. Specifying t4 is the number of threads. By default it runs on 10 threads, but I have specified it 4 times more threads so that it runs faster, and it has found a directory upload. So let's move on to this directory and see what do we have here. Okay, we can upload a file. Okay, so discovering the overly verbose APIs. Okay, so how we can do this? The page that can be used to upload your dog picture, it is slash upload. Okay, with an API driven web app like this, we can see how the application retrieves data to make it dynamic. A great way to do this is burp suite, which can automatically map out the target site's structure as we explore. So let's use burp suite. Let's set my proxy to burp suite. I'm using Foxy proxy. Okay, let's move on to here and let's forward this request. Okay, so let's forward this. Okay, so let's see HTTP history. I guess target it's sitemap now. Okay, okay, dog list. Target. proxy, let's forward it. Okay, I guess now we see get exif data. So let's go to here and we can see the response that it shows Exiftool version source file. Actually, I guess it's showing the detail of a picture. So let's see. Proxy. Okay, now we see get metadata, and here we see title and caption. So let's move here and see how many questions can we answer. What API route is used to provide title and caption for this specific dog image? It is get metadata. As you can see, it says title and caption. So it's slash dog slash get metadata. Okay, I have to turn off burp suite first. API route does the application use to retrieve further information about the dog picture? It's dog slash get exif, I guess. We can retrieve more information about a dog from exif data, I guess. Yes, it's get exif data. Okay, what attribute in the JSON response from this endpoint specifies the version of exif tool being used? It was right here, which was exif tool version, and it's 12.13. Okay, what version of exif tool is in use? It's 12.23. So let's move on, I guess. Okay, so what RC exploit is present in this version of exif tool? Give the CVE number in format this. So let's Google this. Exif tool 12.23 exploit. Okay, now we'll see the CVE. So there is a blog on this topic. The CVE is 2021. Okay, so let's copy it from here, paste it here. Now let's move on to task 4, which is exploitation. Now that we have discovered a potential method of exploiting the box, we should try it. Okay, so this is the vulnerability which we have to exploit to get RCE on the box. Okay, so we have to, I guess, upload an image on the upload. So let's go to slash upload. Okay, why is this exploit interesting? In the Microsoft ecosystem, there is a concept called Patch Tuesday. Security patches for Microsoft products are often released on Tuesdays. Practically immediately after these patches are released, work begins on creating exploits for the vulnerabilities, as many systems will not be immediately updated. Exif tool follows a similar story here. In early 2021, an exploit was discovered in Exif tool that could lead to arbitrary code execution. The exploit was quickly patched before public proof of concepts started to appear. However, many security enthusiasts began to reverse engineer the patch to create the exploit. So I guess it's all the theory here. Understanding the code and the danger. The danger function here is to call eval on line 233. Eval is used to run Perl code that's contained in a variable, and the variable comes from the exif data in our image. Control over code that's executed is our goal. So currently seems like the only barrier between us and arbitrary code execution is the filter found on line 231, which is this filter. And it's worth explaining that equals to and tilde sign that's used here. It's a Perl operator usually used with regular expression, and it can be very complicated. Importantly for us, for the first character after this tilde is s, which is to search, I guess, and replace with the regular expression that follows. Combining that regular expression is also very complicated, unfortunately. There's a helpful comment explaining the intent. Escaping the special characters in the string must protect unescaped dollar sign and at the rate symbols and slash at the end of the string. Another unfortunate discovery is that we can look at the source following our surrounding our filter, which wasn't captured in the differ. Is that this filter also relies on quote marks delimiting the ends of the fields. The quote marks at the end of these two slashes, creating our exploit with Metasploit. So let's use Metasploit here. We don't need this anymore. I guess we will do this both ways. We will do this from Metasploit as well, and we will do this manually. By manually, I means by using a GitHub repository or by following a link. I guess the command for using Metasploit is msf console. So let's Google GitHub. What was the CVV? Let's copy this CVV. Here, GitHub. Okay, I guess this was the GitHub repository. Okay, let's git clone this. Okay, I'm going to try hack me. Typing git cloning the repository, GitHub repository into our machine. Okay, it has cloned it. cd into cve. Gedit our exploit. Ged is it is used to edit files. I'm using it to edit exploit dot and changing the IP to our IP, which is I guess 10.8.130.2, and the IP is this, and let the port it wants to listen on be it 5555. Okay, it has saved it. So let's run this exploit. Python 3 exploit. Okay, let's run our netcat listener 5555, and let's use Metasploit as well. Let's search exif. Okay, Exiftool using this show options. Let's set our lhost to 10.8.130.2 and let the L port be, which is local port bit 4444, and the file name will be msf.jpg. Okay, so let's exploit. Okay, it is at stored at this location. Exit. Let's exit out of this Metasploit. Okay, let's move back a directory, cd into our Tryhackme directory, clear this screen out, and copy this file here. Okay, so let's run netcat 4444 and let's listen on this as well. So this image.jpg is for the GitHub repository, and this msf.jpg is for the Metasploit. So we don't need this anymore. Let's go to here, going down. Let's browse. Let's go to home. Try hack me. Let's upload the msf first, and we will name it Metasploit, and caption be um, hacked, I guess. Submit. Okay, let's see. Okay, our Metasploit one has been uploaded, so let's upload our GitHub one as well. uh, Actually, I'm preparing for OSCP. That's why whenever I see someone using Metasploit or any exploit that is intended to be done from Metasploit, I try to find a GitHub repository of it, or to do it manually. because OSCP doesn't allow us to use Metasploit. I guess let it be GitHub and hacked again. Let's submit this. Clicking on the doc picture, and I guess 6 was the last ID and 7 will be the Metasploit one, I guess. So let's run this. Let's see if we, yes, we have got a hit. The Metasploit one has got a hit. And now let's try our I guess 8 will be the ID for our GitHub one. So let's see, has it got a hit? Yes, it has. We are in. Okay, but it is a bit weird terminal. So let's see if we have python dash c import pty $pty dot spawn slash bin slash bash. Okay, so it doesn't have bash, and it has python command not found. It also doesn't have python on this box. Okay, I guess we don't need burp suite anymore. Okay, generate an image payload with Metasploit. We have done this. Get code execution on the target machine. We have got it. Retrieve the flag located in home slash docpics slash user.txt. I guess we are in the directory. Let's see pwd. We are in the directory ls cat out this user.txt. Okay, deja vu. Let's see if it doesn't have python on it. So let's see how to get interactive shell without python. Okay, linux reverse shell without python. So let's see. Okay, so let's move on to last task, which is privilege escalation, enumeration, and path exploitation. Okay. Okay. Well, I like this shell a bit more. It has bash. Which bash? Yes, it has bash, and uh, the full path of the bash is user slash bin slash path. Okay, let's see. I think it does not have Python, but let's confirm. Which no Python, so it doesn't have Python. So actually, I think for privilege escalation, we are exploiting an suid binary. Okay, it has special permissions allowing the program to use the suid system call. Can allow the process to set its user id. That is, if the process is running by root, we can become root by exploiting it. And privilege escalation, note that we have code execution and our goal should be rooting the box. Fortunately, something should immediately catch your attention if you run ls/lah, which is for listing files, and I guess listing files dash la is for I guess hidden files, and h is for I guess I don't know what h is for, but let's see what difference do we see. I don't see us think difference. They both do the same thing, I guess. So I guess we are looking for is suid bit set. You can see that right here the server manager has a suid bit set, which is s. Usually what we have is read, write, and executable, which is r for read, w for write, and x is for executable. But we have suid bit set as well for this server manager, so I guess we will be exploiting this. So let's get a shell first. Let's get a good shell. What do we have to do? I guess let's run this. Where am I? Okay, now we have got a good shell. STY echo foreground this and reset it. Terminal type. Okay, so let's see. Uh, echo which is dumb. Okay, can we clear the screen? Terminal variable not set. So let's export term equals to xterm. Now can we clear the screen? Yes, we can clear the screen now. So now it's an interactive shell. It's a lot bit good looking, and I can move my cursor keys. No, I can't move my cursor keys, but I guess I can clear the screen now, at least, or the very least. So let's move on. I guess we don't need this anymore. Let's go to Deja Vu and see what we have to do. Okay, so C Linux improves security by essentially setting out rules that processes are made to follow. While C Linux can make hacking a box more difficult, it can make administering a server more difficult as well. So I think it has been disabled by default because developers are lazy. Rather than trying to configure SA Linux to allow the web server to bind the port to 80, the system administrator just disabled it. This is somewhat common approach, but is by no means the correct approach. We should be learning the fundamentals of C Linux and configuring it correctly. With the command get enforced, we can verify whether C Linux is enforcing its rule. The command prints disable. So let's see this. Yes, we see disabled on the screen, which means C Linux is disabled on this box. So let's move on. What does the vulnerable binary do? So when we run the binary, we get a choice of operations. Selecting 0 gives us the status of the web server service, and 1 allows us to restart it. Restarting the servers, which usually require root privileges, so it makes some sense that the binary is set. So as I told you already, that SUID bit is used to run processes. Uh, and we can get the user ID of the process by exploiting the binary. And I guess for root it requires the root privileges for that process, which means rooting, restarting the box. As we can see the source code of the application, we can more easily see the vulnerability. Okay, so the vulnerability comes from the calling system, which is here, without providing a full path to the binary. So it is using systemctl. So let's see where is the path, which I guess systemctl exit. Let's see. Okay, it has killed my terminal. I have killed my terminal. I guess this one, the Metasploit one. I guess I have a one. Let me go see how to interactive shell. I've killed my shell. Okay, just be a bit quick. So let's see if we run this. We without providing a full path to the binary. This means we can create a fake CTL system CTL binary which will run as root and escalate our privileges. We can also run a program called ltrace, which allows us. It's actually for reverse engineering purposes. Ltrace is a tool which allows us to use system to see system and binary library calls. Although it is not installed on the machine, pay close attention to the system seen earlier that provides systemctl without its full path. Okay, explaining the path variable. The path variable tells the shell where to look for binaries that you call by name. For example, ls, which is actually slash bin slash ls, because whenever we just run bash in our terminal, but the whole path of bash is, I guess, user slash bin slash bash. So this is the whole path for bash. Okay, so I guess this shell was nice. Okay, so what am I looking at? Which system CTLs? Let's see the full path. I don't think we require this, but let's see. Oh, so slash user slash bin slash system CTL. So this is the full path. Okay, your shell will run the first binary that matches, looking in each directory left to right. So it goes from left to right. This direction is important. Secondly, the binary system share with an incomplete path on its own. Example. Okay, so let's create a system CTL. Okay, our fake system CTL can be as simple as slash bin slash bash in plain text to start a new shell. Linux treats executable file text files as shell scripts. So let's create a fake systemctl and add it to path and get root. Okay, so let me get a better shell first. Okay, so it is stdy, which is I guess used to set rows and columns. Raw dash echo, which means I guess shows the command we have run as well. And reset. Terminal type, I guess we use dumb. Export terminal equals to xterm. I don't know. Can we clear the screen? We can. Okay, what am I looking at? I guess we don't need this anymore. Yes, we were creating a systemctl shell script, which was simply bin bash, running bin bash. Okay, it is that echo was to show us the output, show us the command we have just run. Chmod, which means changing the permission and making the systemctl file executable. Chmod plus x, we can also use codes like chmod 777, which means make it read write executable for root user and all the other users. First one is for root, second is for the user you are I guess running as, and third is for all the rest users. So let's export the path to specify it. Dash this dot is I guess for let's see what it is for. I guess it is for our current directory. Okay, yes, it has explained it right here. We add dash a, our current working directory, to the beginning of the path. This means that the system will look in our current directory for binaries before searching the rest of the path and find our fake systemctl before the genuine one. So I guess let's run this. Where am I? Where am I? Where am I? Okay, let's see which systemctl now. Let's see the path. Okay, so dash this dot slash means it is the path right now is our current directory, not the actual path user slash bin slash systemctl. Okay, so what do we have to do? We have to run service manager and just get service status. Okay, so it is using systemctl. Okay, so what do we have to do? Simply run server. Let's see. I have I. Okay, I don't have tab autocomplete. Let's run. Okay, I forgot the dot server. If I can type server manager and we'll using 0. Okay, I guess it's okay. Now I am root. Okay, so let's cd into slash. I guess it's, let's see if it works here as well. Yes, I think it, no it doesn't. Where am I? pwd. This still is actually used to go in the roots home directory, but I don't know. So we are in root. Let's cat out this root.txt. Okay, stabilize your reverse shell to ensure that we can run interactive binaries. Okay, we have got a reverse shell stabilized. Find the suid binary. Okay, so let's verify this. Okay, let me paste the root flag first. Let's see, verify based on the output that the server manager program runs systemctl when you run it. So let's see. Okay, okay, it is actually running the server systemctl. Okay, the service is running and it is showing us the commands we have run. Okay, so create your fake systemctl, and so that's it for this room. And I guess that we have answered all the questions and I have tried to explain a few things that I could. So that's it for this video, and thank you for watching.